Hi, good afternoon. This is Bruce McConnell with Locomotive Systems Training. Welcome back. We're still talking about air brakes, and the name of this video was Basic Pneumatic Air Brake Systems Continued. This is LSTV-033. And I just kind of want to reiterate, we're in pneumatic brakes. Remember the last video that we looked at? We talked about in the new modern era, in the year of 2015, there's basically two types of air brake systems. The pneumatic type, which is what we're talking about here, and then there is the electronic type, which we're not going to go over right here right now. But so basically there's two types of air brake systems, pneumatic and electronic. So we're going to stay in the pneumatic field. And again, the system that we're looking at, 26L, is a type of system. It was actually invented or brought onto the market in 1957, so that's not modern era locomotive air brake system, but it's a good braking system. A lot of railroads heavily depend on this system. It's a good system, very reliable, and it works well. So without any further ado, I want to mention something though to you. I have a little note here to remind me how I teach locomotive air brakes. Well, you know, to each of us, learning can take on a different method, a different way, a different attitude, if you will, a different, what's the word I'm looking for here? You ever heard that acronym WIFM, what's in it for me, that type of thing? I'm going to throw something out there, seem a little weird, but the way I teach air brakes, when I teach an air brake class, is I ask the folks in the class, I'll say, what are the components or what are the ingredients to a Big Mac sandwich? Now you got to go back way back in time to figure that out. Now the importance of this is how can I relate a Big Mac sandwich to learning air brakes? Well, I'll go back to the ingredients of a Big Mac. And let me see, and that's all right off the top of my head. It should be 2 all beef patties, special sauce, lettuce, cheese, pickles, onions on a sesame seed bun. And I can actually hear the jingle in my head. Now, how did I learn that? 2 all beef patties, special sauce, lettuce, cheese, pickles, onions on a sesame seed bun. Well, that commercial ran countless times. And there's times that I've watched it, paid attention to it. There's times, or a lot of times, it was there. So what I'm getting at is by doing the repetitive method of throwing out a message, whether you're really in tune or not, you still actually learn that message. And that's how I teach air brakes, and it really works out well. So in each of these videos, what we're going to do a little bit of a review, a few minutes review, to go back what we learned last week. Then we'll progress forward. Then the next video after that, we're going to go back and what we learned the last 2 weeks, and then the week for that week. See how that's going to roll out. And you'll be amazed how well that works when you want to try and understand how air brakes work. Now, a lot of people in the railroad industry and a lot of other people think that railroad or locomotive air brakes is this mystical system out there that only unless you're like really highly certified person do you have the ability to understand, work on, apply, repair, and maintain locomotive air brakes. Well, that might be or might not be true, but the way I'm going to show you here is I'm going to take something that can be very sophisticated and break it down into steps where and when you see it, when we get the circuits, you go, that's really cool, I understand it. But before we get there, I'm going to give you a small sample of some of the components which we did last week that we have in the air brake system that make this whole thing tick. Because here's the thing, here's the key. Once we start talking about the components again, if you don't understand what an A1 charging cutoff pilot valve, if you don't understand what a P2A valve is, if you don't understand what a 26F control portion does, or control valve does, none of this will make sense. So that's why we're going to take the time and go through these slowly and carefully to make sure you have that information. All right, so that's how we relate a air brake training to a Big Mac sandwich. All right, so here we go. Let's review. Remember from last week, this is a 26C automatic brake valve. Here we go. Oh, I got the answer right, yay. What is its function? Let's take a look at it. Remember what I said last week, there's 2 types of valves. One is called the initiating valve, and one is called the responding valve. This valve, go back to one picture please. This valve right here is an initiating valve. You grab hold of that handle, and then what you do, you move that handle from the left to the right into the application zone. You are actually applying not only the brakes on the locomotive, but also on every box car to the very end of that last box car. Automatic brake. controls the whole train. Okay? All right, let's go ahead. Now, go back one, please. Thank you very much. Let me talk about this. This valve initiates applications and releases of both locomotive brakes, there it is, and train brakes by controlling equalizing reservoir pressure, which results in controlling brake pipe pressure increases or decreases. Wow. I just said a whole mouthful, didn't I? So we're going to talk about that here in a little bit, but let's go ahead and move on. We're going to come back to this. Remember, this is just a review. What is this part? Well, if you remember from last week's video, this is the SA26 independent brake valve. And my question is, we talked about it, what does that mean, SA? What does the SA stand for in air brakes? SA stands for straight air. Well, remember when we talked about back in the steam days, a couple of videos where the brakeman on top of the Bosch cars applying the brake wheels and releasing the brake wheels, and snowy and rainy and nasty and all that stuff? Okay, well this here, SA straight air, means air brakes right now. If this independent brake valve handle is in release, right over here to the left, and you apply that into the applications going from left to right, you will see brake cylinder come up just virtually immediately. Boom. Okay, so that means anytime you want independent brakes without locomotive consist or single locomotive, you got brakes right now. Let's go back a couple slides. I want to talk about something. On this brake valve here, on the 26C automatic brake valve, you move that handle, you don't get brake cylinder right away because several other key events have to occur first before we actually get brake cylinder. Okay? All right, so again, the automatic brake valve operates completely different than the independent brake valve down below here, in that this controls the train and the locomotives, or should I say locomotive and train brakes. This little guy right down here, let's go ahead and roll forward. Keep going. Yep, we already talked about that. This little guy right here, if you remember from the last video, this guy only controls the brakes on the locomotive consist, period. This brake signal that this thing creates does not go to the cars. It only applies to either a single locomotive or what we call multiple unit, or a consist, where there's 2, 3, 4, 5, whatever the number they put on there for that train. All right, so independent brakes. These brakes work independent of the automatic train brakes. I can apply the automatic brakes, and then I can also augment that application with some independent brakes, which makes the locomotive brakes give it even more braking effort. Okay? All right, let's move on. Again, we're talking about the function of it. As the name implies, this brake provides independent control, pipe 20, of the locomotive brakes, only separate from the train brakes. Another function of this valve is to provide an air pressure signal, pipe 13, to the 26F quick release valve to exhaust an automatic brake application. Let's go back to that picture for just a second. What we just said and read, or read and said, is right here. Okay, this valve works independent of the automatic brake located above it. Okay, this valve is responsible for 2 air pipe pressures that it has the ability to create. Remember, this is an initiating valve. Okay, it starts something. It initiates an action. This guy, when I move the handle from here to here, will put air pressure in a pipe known as pipe 20. Okay, when I take that independent brake valve handle and push the handle down, and it can be anywhere from full application, clear back to release application, I can push that handle all the way down, and I will create a pipe 13 pressure, which is also known as actuation. So if I want to actuate the brakes off, and in the rail industry they have a term for that called bailing off, or bail the brakes off. And what will happen is it'll take an automatic brake application that's gone from the locomotive close to that 150th car, and when you push this handle down in any handle position here, I will send a signal over to every control valve in the locomotive consist, and I will eliminate the automatic brakes. There'll be virtually no brakes on the locomotives, but the brakes on every car, all 150 cars, has been applied and is now slowing the train down, and the locomotive literally is being hung on by that coupler. It's called, you're stretching out the train, and allows for a nice control slow down, or a nice control slow down and stop. Okay? All right, so let's move on. That's the independent brake valve, and again, creates pipe 20, and it also creates pipe 13. 20 is application, or independent application and release. Pipe 13 is actuating. And again, are we going to go over this again and again in this video? Absolutely. And this part is, this guy right here is known as a J relay valve. Okay? Now, let's talk about the term relay. Well, The Olympics, I think, what, last year, I believe? Were they not? I'm looking at my team here. I think it was. Anyway, yeah, I think that is. Anyway, that was the Winter Olympics. But in the Summer Olympics, wherever it's held in the world, they have a relay race, or several of them. Well, a relay race is where you have 2, 3, 4 runners, however many determined by the length of the run. But each person that's in that race, the first person has what they call a baton. And as they run, they take a run with this baton, and then as they run up to the next person that's going to hand that baton off to, that person is ready, and they'll take that baton. In this case, our baton is not a baton. Our baton is an air brake signal from either the automatic brake valve or the independent brake valve. That gets handed off to this guy. So let's back up. Let's back up for just a minute. Go way back to the 26C automatic brake valve. Okay, I know I'm jumping around a little bit, but we have to do that to get this straight. This valve, okay, this valve right here is also known as what I would call a brake pipe regulator. Move the handle back and forth, brake pipe goes up, down, up, down, up, down, okay? Anyway, so this valve tells the control valve to apply the brakes on each locomotive and each car, okay? And it does it through what they call a brake pipe reduction. So this guy sends a signal out, which is initiating. Go to the next one, the SA26, please. Keep going. Keep going. There's the SA26. These two valves, ladies and gentlemen, are nothing but signal initiators, if you will. This guy sends out a signal to the control valve in each locomotive in every car. This guy sends out a signal to the locomotives, period. Keep going to the J relay valve. Now, the J relay valve, which we're going to show right here, is a responding valve. That is a very reliable valve, and it'll sit there all day waiting for a signal from either the automatic brake valve or from the SA26 independent brake valve. All right, and the G relay valve's function is, this is a responding type valve. It responds to an air signal from either the independent circuit, which is what I said, pipe 20, or an automatic circuit, pipe 16, which is what we also said, that provides a large volume of air, main reservoir air, to the brake cylinders. The diaphragm or diaphragms contained inside this valve determine the output of air to the brake cylinders. So, back up with the one picture, please. Okay, here's the J relay valve, okay? At the top of this, now I know you can't see it all, but at the top of this is main reservoir pressure piped into a 1-inch pipe, okay? And it's always there when that locomotive is running, either lead or trail, okay? Or even dead, it can be, they'll have main reservoir there. And we'll talk about dead and train much, much later. Anyway, so I always have a large volume of air there, up to 130 to 140 pounds. I put either one input with an automatic application or two inputs if it's an independent application. And what will happen is, with a 1-inch pipe of main reservoir going to this, I can outflow a whole bunch of air to the brake cylinders really, really quick. Okay? So if I have an opening that big with 140 pounds in it versus an opening that big with either 45 pounds for the independent circuit or 55 to 62 for the automatic circuit, it would take a while to fill those cylinders with air, wouldn't it? But by the use of a J relay valve, or there's many, many different types, the J relay valve will take that signal, multiply it, or non-multiply it, or, well, actually there's 3 types of J relay valves. Let me back that up. There's a non-multiplying valve, J relay valve. There is a multiplying up J relay valve, and there's a multiplying down J relay valve. So let's talk about them. How many types of J relay valves are there? There are 3. I must be psychic or psychotic. There are 3 different types of J relay valves. Non-multiplying, J1, J114B. That means whatever signal I input, I will output the exact same pressure. If I put 45 pounds in, I'm going to get 45 pounds to all the brake cylinders. If I have a multiplying up, J1 414, J1 616, J1 818, or a J200, I put that input signal in to the J relay valve, I will get, let's take, for example, a J1 616, which a lot of locomotives have. If I apply the independent brake fully, I'm going to get 72 pounds of brake cylinder pressure out. What that means, that's a multiplying up, because I only had 45 going in. It's part of the magic of the air brake system, which will happen down the road. Multiplying down is for locomotives that have gone in and they've had the brake shoe mod gone through, where they take off the cast iron shoes and they put either a high friction or a low friction composition shoe, which has much more greater coefficient of friction and greater stopping pressures. With that being said, they actually have to take that air pressure that goes to the J relay valve and multiply it downward. In other words, if I have 45 in, I might have 37 pounds coming out. And that's so we don't lock up the wheels at all the proper pressures. So 3 types of J relay valves: non-multiplying, multiplying up, and multiplying down. Okay, let's go to the next one. The last component I want to talk about, and here it is. This is the control valve, the 26F control valve. I must have got an A for the day. Its function: this valve is used in the automatic brake circuit. It consists of 3 components. 1, a pipe bracket, 2, the service portion, and 3, the 26F quick release valve. All right, let's go back to this. Okay, let's go back a little bit, one more, there we go, perfect right there. I just want to show you what those 3 parts are. I don't know if you see it real well, but this great big chunk of iron right here is what we call the pipe bracket. Now the importance of the pipe bracket, it has, number 1, a 40 cubic inch volume reservoir built inside of this. And that's designed to absorb or allow this brake pipe air, what's known as quick service air, a place to go to when a reduction is made. I know that doesn't make sense right now, but that's actually part of it. Between the pipe bracket and the service portion, which is this big monster here, weighs over 90 pounds, between this service portion and that pipe bracket, there are 11 chokes and orifices inside that valve that do a whole bunch of different things. So it can be complicated, sure, but we're going to make it uncomplicated. So pipe bracket, service portion, and this guy right down here is known as a quick release. Remember we talked about the independent brake and pushing the handle down, and we're gonna get rid of the automatic brakes from this guy right here. Well, that's it right there. And I know it don't make a lot of sense, but don't worry about it. It's really confusing if you let it be, and don't, because we're gonna go over this again and again and again, so you have a clear understanding of it. Okay? Okay, now let's learn about some new parts, shall we? This is a P2A brake application valve. Now, before we go any further, I always want to throw this out there. Well, just hold right there a minute. Let's talk about what P2A stands for. P stands for penalty, 2 function, and the A is application valve. Okay, P2A. It's used in the penalty circuit. Okay? A lot of folks in the railroad industry and a lot of other people that are interested in the railroad industry get this component and an A1 charging cutoff valve all mixed up. And it's really, really quite simple. P stands for penalty. And the way I always teach everybody in the class is let's see, today we started out in the comparison between the ingredients of a Big Mac and air brakes. Now I'm going to take you to a hockey game. Who knows, maybe you're eating this Big Mac at the hockey game. I don't know. Anyway, when I think of the P2A, I think of hockey, and I'll tell you the reason why. You got both teams out there in the ice, and they're all battling around, and let's say one of the players does something bad or wrong. And he gets called timeout, and they put him in a, what? A penalty box. He's out of the game for X amount of minutes and time or whatever. Shame on him, bad person. Now, so the rest of the team has to play on without him. Well, this is what happens, that's what this guy does. This little valve right here is in charge of making sure that train is properly controlled. So let's go down and let's find out the details of what this valve does. Function: this is a responding type valve that works in conjunction with various safety device components such as overspeed magnet valve. What if the engineer exceeds 75 miles an hour in the States? That's what it is in the United States. Coded cab signal: that is a vigilant system that is in certain territories of certain railroads, if equipped. Crew alerter magnet valve, if equipped. A crew alerter is what they call a vigilant system that is designed to make sure the engineer A doesn't fall asleep, or if he were to have a heart attack or become incapacitated, or the conductor or whatever, the whole crew is overwhelmed, what would happen is there's that little yellow button on the control stand that engineer has to continually just hit, not bang on or hit it with a hammer, just tap that little button with a hammer, or with your hand. Thank you very much. I'm just checking to make sure you're still awake. With your hand, and he has to do that like 15 every 30 seconds, depending on the type of system. It's a vigilant system. I'll leave it with that. Automatic train control, if equipped, similar to coded cab signal, but used on different railroads. And other vigilant systems. When activated, the P2A will provide, oh, by the way, one coming out that we don't have listed here yet is called positive train control. Down in Southern California a few years ago, there was a really bad train wreck, collision. Somebody, I think it was on a cell phone, and I don't know if they went through a signal or what, but anyway, they wound up colliding with another train and people got killed. And so as a result, now all the railroads in the United States are going to have to install this thing called PTC, which is positive train control. In other words, it's a vigilant system, and it will make sure that if the operator of that train can't control it, that system will. Okay, when activated, the P2A will provide a penalty brake application. Also activate the power cutoff switch, PCS. The P2A functions in the penalty brake circuit. That's really, really important you understand that. When the PCS switch is activated, two events are going to occur. Number one, drops the load, generator alternator excitation stops, and returns the engine to idle. Governor speed throttle is stopped. So when that little red light comes on, it says PCS. Now the engineer has had excitation of that locomotive. The generator no longer generates power to the traction motors. That's taken away. And the engineer's lost governor throttle. He lost engine speed. That train's going to come to a stop. Okay? Go ahead. And how do I know that? Because we had a penalty brake application and we activated the PC switch. All right. The A1 charging cutoff pilot valve. Whew, that's a long name for a valve. But this valve is it's completely different than the P2A. Because remember, the P2A operates in the penalty circuit. Let's move on. Here we go. Hold on to your hat. Its function, this valve is a responding type valve. That valve will just sit there and watch brake pipe all day long. He doesn't care what brake pipe does, as long as he doesn't do it at an emergency rate. Let me explain. When the pressure in brake pipe drops to 0 psi at an emergency rate, equal to or greater than 900 feet per second. That's about, and I don't know, I'm not much into, I don't even own a gun, but I've been told that 900 feet per second is about the speed of a slow 22. Okay, and the A1 charging cutoff valve will activate. 3 events occur. Brake pipe charging cutoff occurs. Brake pipe must remain at 0 psi. Number 2, power cutoff switch. PCS is activated, drops a load, and returns engine idle just like the P2A. And 1 minute of emergency standing will occur. This is pneumatically timed. Whew. A lot of things happen in a P2A. All right, number 8 vent valve. This guy here, let's go to the next page. And this is located on the running board. The number 8 vent valve ensures a complete venting of brake pipe air locally within and around this valve. When the air pressure in the brake pipe begins to reduce at an emergency rate, there we go, equal to or greater than 900 feet per second. Note, this valve causes a serial action within the brake system. Brake pipe system is like a domino effect. On the number 8 vent valve, there's several other types. There's a KM2 vent valve. There's also a VX vent valve that we use in the electronic air brakes. We don't mix those up. This guy acts like a domino. Let me explain that. When I was at work one day, main line was right here, and I just walked out of my office at the end of the work day, and a brake pipe hose burst right smack in front of him, and it did it right in the middle of the train. And what was really, really interesting was you hear this pow. That's when the brake pipe vented, and then you hear all these pow, 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 pow. So I'm literally hearing every vent valve lights off, this vent valve lights off, this vent valve lights off, that valve. Because it happened in the middle of the train, they went like this, pneumatically, from the middle to the front and from the middle to the end. That was really, really cool. But what would happen if I burst the train line hose near the front of the train? The emergency would occur at the front of the train and propagate, acting like a domino. This one knocks over this one, knocks over this one, knocks over this one, all the way from the front, all the way to the back. But what if we had one that went from the back of the train to the front, the same thing? It only would be a domino effect. This one lights off, this one lights off, this one lights this one, all the way from the rear to the front. Very important valve used in the emergency circuit. Number 8 vent valve. Okay? We already talked about the functions, but now I'm going to go ahead and talk about the double check valve. Double check valve, there's a rack of them or a row of them here. Some have, like this one only has 4. There's some that have 6, 8, and even more. Okay? So let's talk about what the function of it is. This valve permits directional control of a device from 2 different air sources without interaction between the air sources, whichever pressure is greater. Move on. Guess what? That's it. Whew, that was a lot of stuff we talked about today. And again, we're going to review this stuff, so guess what? Our review is going to get longer. And if you have questions, email me or call me, because this is really, really cool stuff. Okay? Go to our website, take a look at it, www.lst-ca.com. And by the way, Some of you are thinking that is a 1. There are no numbers in our web address. It's www.lst-ca.com. Go to that website, check it out, send me an email, give me a call, and we'll go from there. Thank you and have a safe day.